In this video, I provide an explanation for question 1 of homework 4, in which we are asked to find the CDF and the PDF of y. Given y is as a function of x, a discrete function of x, given these conditions here. So when we sketch y out, given this, we have some sort of step function and a linear function in x, and another continuous function. So this therefore shows that y lies in the range -1 to 2, and therefore the CDF of y is 0 for y less than -1 and 1 for y greater than 2. So if you concentrate in this range of y between -1 and 2, for y is equal to -1, here we see that this occurs for x greater than or equal to 2. And this, of course, we know it as the 1 minus the CDF of x at 2. Similarly, for y is equal to 0 and y is equal to 2, for y is equal to 0, we see that x lies between 0 and 2, and for y is equal to 2, we see that x is less than or equal to 0. So we plug those in here and here, and we use the property of the CDF to obtain this and this. Now in the range between -1 and 0, here, where y is equal to -x plus 1, the probability that y is less than y, substitute for y here, this value, and then make x the function, we get 1 minus y, and this becomes a familiar looking function of the CDF of x. So this becomes the CDF of y as this, and we differentiate the CDF of y to get the PDF of y, which is this. So we summarize the results. The PDF of y is this, as obtained from these results here. We use some delta functions, some impulse functions to make it more concrete. And then as well for the CDF of y, this is what we get. And then what you're left with is sketching out the results. The PDF has a couple of impulses with the areas as shown. And it has a function of y between -1 and 0, which is a curve of that form. On the other hand, the CDF of y, which is given here, is 0 for y less than -1. It's a function of y between -1 and 0, which is here. And then it is a constant function between 0 and 2, and then 1 when y is greater than 2, which is shown here. The constant function up to 2, and then 1 after y is equal to 2.